Good morning, Algebra I Honors class. I'm trying this again. Hopefully this will be a successful video for you. As we always do, let us begin our class with a prayer. En el nombre del Padre, del Hijo, del Espíritu Santo. Amén. Dios te salve María, llena eres de gracia. El Señor es contigo. Bendita tú eres entre todas las mujeres y bendito es el fruto de tu vientre Jesús. Santa María, Madre de Dios, ruega por nosotros los pecadores, ahora y en la hora de nuestra muerte. Amen. And my special intention is that we all are safe, well, healthy, and that we get through this. And hopefully we'll get to see each other before everybody gets to high school. All right? En el Padre, del Hijo, del Espíritu Santo. Amen. Today's lesson is going to be simplifying radicals or square roots. Now, we did square roots back when we solved some quadratics and when we did factoring out perfect squares. So square root is in your memory, it's in your notes. So we start off with the first example, a very simple one. We have the square root of 25. Square root of 25, everybody knows, is 5. All right? We have the next one where we have a sign, a negative square root of 49. Now that's not the square root of negative 49, it's the negative square root of 49, which we just carry the sign over, negative 7. Same thing with the plus or minus, square root of 100, we still have plus or minus 10. Now remember that our answers will not be plus or minus. Remember when we solved some of these quadratics, we had to put plus or minus. That was when we're solving them. We're simplifying them here, so when we solve them, you'll see that, all right? Now, another one that we have is larger numbers. Now, 225. Now, you may know it, you may not know it, but 225 is a perfect square, and it's 15. Now, let's say you didn't know that. You could break this up, all right, into the square root of 9 times the square root of 25. All right, because 25 times 9 is 225. Then you say, okay, the square root of 9 is 3. The square root of 25 is 5. Therefore, my answer is 15. Notice how we get the same answer, even though you break it up. So in case you don't know, you could break it up. We go to another one, fractional one. How about this one? The square root of 36 over 121. Well, we could rewrite that as the square root of 36 over the square root of 121. And therefore our answer would be 6 over 11, 6/11. All right? Now, on these next ones, pay specific attention how it's written. So for example, the square root of 9 squared. Well, square root of 9 squared, let's square 9, so we get radical 81. The square root of 81 is 9. Right? We could also rewrite this as this. The square root of 9 quantity squared. We could put that on the outside. Well, again, what's the square root of 9? 3. If we square 3, we get 9. Notice, they mean the same thing, solving them in different ways. One other way, write it like this. The square root of 9 quantity squared. Now, if you remember very carefully, when we were teaching about opposites, when we did equations, we did the opposite of addition, subtraction, multiplication, division, and so on, doing its opposite. In this case, you should remember that what the square root and squaring a number are like opposites of each other, and they do cancel each other out, so therefore my answer is 9. Notice the work involved in each step, how we can simplify it. So whenever you have the square of a square root, it basically cancels itself out, and you're left with, this is called a radicand. The number that's underneath the radical, the radicand, okay? All right, so let's take another one over here. The square root of a fractional one, the square root of 3/7 quantity squared. All right, well, that technically means the square root of 3 squared over the square root of 7 squared, which is square root of 9 over the square root of 49, which is square root of 9 is 3, square root of 49 is 7. Now, based on what I told you a few minutes ago, this then could be rewritten as a square root of 3/7 quantity squared, where you know the square root and squaring are the opposites. They cancel each other out. Your answer is 3/7. But I didn't show you the work. I showed you the steps, because some of these are not going to be as simple, and you're going to have to work with them that way. All right? Very good. Now, I'll move over here. With some of these problems, as you saw with most of these, all of these here, they were perfect squares. We dealt with them. Well, let's deal with one that's not a perfect square, like the square root of 75. Now, you should know that there are no two numbers that when multiplied together give you 75. But as we did with example number 4 and 225, we broke it up, square root of 9 times the square root of 25. We can break this up into the square root of 25 times the square root of 3. The only caveat to this is make sure that when you get a factor of this radical, one of these two has to be a perfect square in order for it to work. If both of them are a perfect square, like it was for 225, the 9 and the 25, since those 9 and 25 are both perfect squares, then that number is a perfect square. Here you can see it's not that fact, because one of these is not a perfect square, 3 is not a perfect square. But I can simplify this now to the square root of 25 is 5 times the square root of 3. We just bring that there, bring it along. This square root of 3 does represent a number. Right now, I'm not worried about the representation or the numerical value of square root of 3. If you look it up in a book or say what's the square root of 3 as a number, it'll give you 1 point something. All right? But either way, I'm not worried about that. My answer is going to be 5 square roots of 3. Let's try the last example I have here. 2 times the square root of 112. Now we have a number on the outside. Okay, no issues. I'm going to bring that 2 with me. Now, 112. You might think in your head, 112, does it have factors? 2 factors, one of which is a perfect square. You really have to do your math on some of these numbers and look at all the perfect squares. You know, you have 1 squared is 1, 2 squared is 4. See if something that divisible by 4. 3 is 9, 16, 25. If you see this number is divisible by 16. 16 and 7 give you 112. 16 is a perfect square. So you have to really do your math and check it out. Now what I'm going to do is simplify that. So that becomes 2 times 4 radical 7. I can simplify this. 2 times 4, 8 radical 7. All right, those are the examples that you're going to have. Not too difficult this week. Next week we'll get into more complex ones, all right, a little tougher ones. But this should keep you busy for this week. I've already sent you a copy of your assignments. Monday and Tuesday, Section A, I think 1 to 24. And Section B is Wednesday and Thursday, 1 to 24. All right? Have a great day, Algebra I Honors students. Again, I miss you. I'll be sending you some information on Spanish assignment, and also I will be sending all of you a little bit of information about our panel if we want to continue that and see who would like to work on that. So I really would like to get that done. All right? Have a great day. Bye-bye.